Well, guys, welcome back to our YouTube channel. In the previous video, we talked about what sine rule and its application. Okay, how we use sine rule. We talk about how to derive it, the expression. And so in this video too, we are going to be talking about what cosine rule, which is another rule that is used to what solve triangles that are what non-right angle triangles, right? So in order to solve triangle, you are going to assume what you are going to consider this triangle what ABC. But what you can realize is that the sides are not what equal and the angles also are not what equal, right? And this is a perfect case for what right angle triangle. Like we did in the previous video, we are going to what find the perpendicular bisector of what B what C from what AB from what C, right? We are going to drop to find the height. So we are going to divide this triangle into what two right angle triangles, right? Two right angle triangles with a height each. Now you realize that the B is opposite to angle B, A is opposite to what angle what A, right? So there should be what this whole length here is what C. But then if we make this place X, this now be what C minus X, right? So we are now letting what from A to D to be equal to what X. Then from what B, D will now be what C minus what X, right? C minus X. Yeah. Now what you are going to do is you are going to write what the Pythagoras expression for the two triangles. For the two right angle triangles, right? So we are considering first A, C, D. And when you write the Pythagoras theorem expression, you get B squared is equal to what H squared plus what X squared, and this is what you have over here. And also you get cos of angle A to be equal to what the adjacent over what the hypotenuse. So you get that, and when you do here, when you find X will be equal to this, and then you can get this expression. Now for triangle what BCD, which is this other side BCD, if you write the expression, the Pythagorean expression, you get what A squared is equal to what this whole expression squared plus the height squared, right? And when you expand, this is what you get. You do your expansion, you get this, and then what you realize that we have what X, which is the X that we have over here. Then you have what X squared plus what B plus A squared, which is what we have over here. It means that we can replace this whole thing by what B squared, and we can replace the whole X here by what B squared minus B squared cos what A, right? If we do that, substituting what equation 1 and 2 inside what this equation, let's say 3, gives us what A squared plus A squared is equal to what C squared minus 2CB cos what A plus what B squared, like we talk about, right? So this is the expression for what cosine rule. Okay, this is our expression for cosine rule. So if they ask you to like prove the cosine rule expression, it's as simple as this. Just divide the triangles into what the triangle that you are given into two right angle triangle, and write your expression for Pythagoras theorem for each of them, and then what compare, you get this expression. Now the next thing we are going to do is, okay, so let's just, so what Pythagoras theorem is just try the cosine rule is just trying to say is that what if you are asked to like, so we can find this expression for various sides, right? So with respect to this side, if you are looking for this side, it will be what this side squared is equal to what this side squared plus this side squared minus 2 times this side times this side cos of the angle that is here. Similarly, when we are looking for the side, this side, it will be this side squared is equal to what C squared plus what A squared minus what 2AC cos of the angle what B, right? Yeah, so that's what you get. Now we are going to see the cases where we use what cosine rule, right? So we use cosine when we have the length two what length, like two sides of the triangle is given, and the size of the angle between them is also given, right? So the angle, so we have these two sides are given, and the angle that is between them is also what is also given. Then we can find what the third side, right? Okay, Now, so let's see an example case. So this is just the case one, right? We'll look at case two too. So this is just case one where we have two sides 4 and 7 are given, and then the angle between them is also given, which is 48, and we are asked to find this. And to write this expression, we use the cosine rule, and the cosine rule states that a squared is equal to b squared plus c squared minus 2 bc cos of the angle that's opposite to the side that we are looking for. And when you write this expression, you get a squared is equal to this side squared plus this side squared minus 2 times this cos of 48. And when you solve, you get your a to be 5.25 centimeters. That's 2 decimal places. You can do it at 3 decimal places also. Yeah. So this is just one of the first case of using the cosine rule, right? Now let's look at the second case. The second case is when you are given all three sides and you are asked to find the angle, right? So in this case, you see that you are given all the three sides and they are asking us to find the angle, right? So in this case, we'll use this expression of the Pythagoras theorem. It's just the same as this expression, cos of a, right? So in this case, they just made cos of a the subject, so they push these ones to the other side and divided by this one, right? So that's what you get. So you just do the substitution of this one. So we are looking for the angle a, and its opposite is 8. So when you write the expression, this is what you get, and then when you simplify, you get this. You realize you have negative, right? So since we have negative, this means that our angle a is big, it's obtuse, okay? It's obtuse. And when you solve, you get 104.48 degrees to 2 decimal places. So this is the second case, like the second use case of the cosine rule. So you can practice with more examples, and if you find any problem, you can just reach out to us and then we'll solve it for you.